basically today this video will talk about integrator and trend of graph. Okay, I'll just skip this. Okay, I'll just skip this part, and perhaps I could place it over here. So hopefully I can clear away this video quite fast. Okay, so yeah. So this is basically the trends of Nyquist. Okay, this simple Nyquist plot. Okay, trends of different Nyquist plot. Okay, so if you have a 1 over s, okay, a very simple, we call all this things, we call it integrators. Okay, 1 over s is the first order integrator. In this case, we call it simple integrator. And then if it's s squared, it's actually double integrator. If it's s cubed, it's triple integrator. And if it's s4, it's quadruple integrator. So this is simple integrator, double integrator, triple integrator, quadruple integrator. As you can see, if you have a simple integrator, you're coming in this direction, double integrator, you're coming from this direction, and so forth, right? And how do we get that? Okay, if you still remember our phase angle, so we'll just do it out fast. Okay, I don't know where I stopped, but yeah, it took a long while to write this thing. So 1 over s is equals to, s equals to j omega, right? So 1 over s is equals to 1 over j omega. And then the theta angle, okay, the angle is equals to minus tangent. If you remember, because if you were to check it out, this 1 over s squared, 1 over s cubed, or 1 over s4, is all poles, right? They are all poles. So therefore, if you remember last video, we talked about poles. We derived that poles should be negative tangent, right? We generalize it. And therefore, in this case, it should be negative tangent. Okay, since there's only imaginary number, there's no real numbers. Okay, typically there's some this imaginary plus some real numbers, right? But in this case, there's no real numbers. Therefore, omega divided by 0 goes to infinity. Right? If you remember the equation, okay, and then this is the imaginary, and this is the real, right? So if, and this is the opposite, this is adjacent, right? And then inverse O over A. So if the real axis is at this point, that is, it didn't move, definitely it's 0. So therefore, therefore omega divided by 0 is infinity. Hope you understand. So it is simply that, and therefore you have negative 90 degrees. Okay, this as I just repeat again, this negative derived from last video. We talked about phase angle. Y poles is negative and y zeros are positive 90 degrees. And with this said, this is only the phase angle. Let's talk about the magnitude. Okay, the magnitude as itself, since it is 1 over j omega, what I can do is actually to multiply or conjugate. So in this case, this value is actually 1. I am just simply rearranging. So therefore, minus j omega times 1 is equals to this. And then minus j omega times j omega is simply omega squared. Okay? And therefore, because minus j times j is equals to minus j squared, right? And therefore, j squared is equals to minus 1, so minus 1 is equals to 1. So, I hope you get what I mean. So 1 times omega squared, because omega times omega is equals to square. Okay, so therefore, I have, so and then I cancel. I have 1 over omega, and then j, right? So, yeah, wait, oh yeah, minus, yeah, okay, so this minus still stays here. So minus 1 over omega j. So as you can see, with this information, let's zoom out. So as your omega increases, as your omega is equals to 0, you're coming from negative infinity j. True? So as your omega increases, let's say your omega is equals to, let's say 1, and maybe 1 maybe 2 lah. If your omega is equals to 2, you'll have minus half over here, right? Let's say this is minus 1. this is minus 0.5, right? So as your omega increases, you're moving towards the you're moving towards the origin. Okay, so this is where omega is equals to minus infinity, and this omega this omega equals to infinity. This sorry. Okay, this is the thing. Okay, this is the thing, right? So as you can see, it's minus 90 degrees. It's coming downwards in this minus 90 degrees. If it's going this way, it's 90 degrees. But nonetheless, typically we are coming from here, so it's minus 90 degrees. I hope I didn't confuse you. Now the tricky part comes in when you have a higher order. Okay, now this is x squared. Okay, so we have 1 over j omega squared. Okay, s equals to j omega, so this is j omega squared. And then I just factorize that out. I have two terms, 1 over, so I have 2 of this thing over here, right? Then simply I can also rewrite this in terms of this. So since you know that j omega squared equals to minus 1, and then omega squared, so 1 times omega, minus 1 times omega squared equals to this one over here. So I just simply rewrite it. As you can see, this is actually the real value. Just now that one is imaginary value, that's why I'm coming from negative imaginary side. So in this case, we are coming from real value. Okay, in this case it's negative real, so we are coming from here. So as omega increases, let's say if omega is equal to 0, right? 1 divided by 0, negative 1 divided by 0 is actually negative infinity. So as you slowly increase your omega, let's say this is minus 1. So let's say your omega now is equals to 2. So therefore you have minus 0.5, right? So 1 divided by 2, so this is minus 1. Oh yeah, omega squared, sorry. So it's omega. So it will be like a lower value. Okay, so it will be 0.75 lah. Okay, so maybe I should rewrite. So when omega is equals to 2, okay, so minus 1 over 2 square is equals to minus 1 quarter, which is minus 0.25 lah, over here. So it's moving in a so-called a more faster way, okay, compared to here. So this is somewhat moving in a faster way because of the exponential term over here. Okay, but nonetheless, this is the thing. And then this is only the magnitude. Okay, we're talking about real value in the magnitude. And then for the phase angle, since it's minus tangent, because since it's the real value, if you remember, this is the imaginary, this is the real, and then this is opposite, this is adjacent, right? And then tangent inverse op over adjacent. So if imaginary divided by real, right? So imaginary in this case is 0 because we only have real values. So 0 divided by any real value is still 0. So tangent inverse 0 is equals to 0 degrees. But since you don't know, but 0 degrees can be here, can be here, can be anywhere along this line. So therefore, since we know that our magnitude is coming from negative, okay, negative infinity, we can deduce that it is actually negative 180 degrees, right? Makes sense? Yeah. So therefore, this clear away the 1 over s, the simple integrator and the double integrator. Okay. So similarly with the same analogy and harder to prove, okay, is that now this is 1 over j cube on omega cube, okay, which is j cube is actually minus j, okay, because j square is equal to minus 1 times j, right? So j square times j, so this is minus 1 times j, that's the thing now, okay? So this is why I have minus omega cube j. And then if I were to break them up into this portion, you can see that we actually have this term the same as this one, and this term the same as somewhat the same as this one. Okay. So this whole term, okay, this whole term is actually the imaginary axis. right? Because anything modelable by j is j. So they are coming up from here. So how do we decide that it's coming from here, right? It's decided by the angles. Okay, angles for this double integrator is actually minus 180 degrees to prove, and then that for the simple integrator, which is the first order one, minus 90 degrees. So you are minus 90 degrees plus minus 180 degrees in a certain sense. So we are actually coming from here. So you are actually coming down from a positive from a should be positive, right? Hold on. Here comes the little trick lah. Okay, as I say earlier, as I go increasing the order, things becomes a little more complex. Okay, hard to analyze and explain. So as you can see, this is also although this is negative. Okay, this whole thing is negative. You are coming in from 270 degrees. Okay, so as your this omega is equals to 0, okay, everything becomes to 0 coming from negative infinity. Okay, it's in this sense it isn't coming from here, right? Because you're actually coming from here. So whether you're coming from negative infinity or positive infinity, it's not that sense. It don't make sense anymore. Okay. Nonetheless, you're coming from negative infinity. From negative 270 degrees. Okay, negative 270 degrees is actually from this direction, right? So therefore, it is from negative from here towards the side. If it's infinity, we are talking about negative 270 degrees, infinity from this side. This is infinity now. So you can see it's a little complicated now. Let's come back to the thing. Let's say you see this is negative 90 degrees, right? Okay, and then it's coming in a negative, and then if you were to come down from infinity is actually this thing, so it's just flipping around. So negative 270 and negative 90 is just a flip in the 180 degrees. So as you can see, yeah, it's pretty much abstract. But as the order goes up, okay, one key thing, as the order goes up, you can see that actually the so-called it increases faster. Okay, the omega increases faster. I mean the so-called the output, the response move faster. What do I mean? Okay, let's say if I sub in omega is equals to 2, right? In this case it's 1 minus 1 over 8. Okay, so therefore it's minus 0.125. Right? So just now in this case we have square, right? So it's minus 1 quarter, which is equals to minus 0.25. And then in this case, this is minus 2. Because as I sub in omega is equals to 2. Okay, these are my values. Why am I over here? These are all my values, subsequent values. So this will be like minus 0.5. So you can see, if as your as your degree increases, you are actually moving faster towards your original point. You're actually moving faster towards your original point. Okay. So nonetheless, if this is minus omega 4 equals to minus 2/4, it's minus 1 over 16, which is way too fast. Okay, you zoom in. If it's omega frequency equals to 2, you straight away come here. Whatever. But I hope you get this trend. Okay. Yeah. So let's do the last part. Okay. So 1 over s4 is equals to j over 4. J to the power of 4. J to the power of 4 is actually equals to 1. Right? So therefore it's 1 over omega quarter. And you can also split it out into 1 over negative omega square times 1 minus. So minus times 1 equals to plus lah. You'll get back this one. I just want to show that this portion is 2 times this one. Right? So therefore it's coming in the opposite way now. You see? So as you can see, since this is two of this, okay. So this quadruple integrator is two times, two exponential times of this one. Therefore, it's coming in this direction now. Okay, minus 360 degrees. Make sense? And therefore, as your omega increases, okay, from equals to 0, if it equals to 0, everything becomes to infinity, right? From infinity, it comes back down, okay? So from infinity, it comes back down to here. And then, if you were to remember, this is from minus infinity, and it comes back down. This is from, so-called, so I have a doubt lah, okay? I don't know why this should be, in fact, infinity lah. Because as you can see, this is coming from negative infinity now. And then this is definitely coming from negative infinity, right? As omega frequency increases, is negative j, so it's coming from all this side. However, this is negative also. That's why it's a little abstract over here. That's why as I say, you just know the trend, that's all. Okay, the symbol, the step. Let's conclude, okay, but I haven't conclusion yet. Okay, that's just to conclude that what are the findings that we can find. Okay, is that as your integrator becomes higher order, okay, S1, S2, S3 to the power of 4. As this one increases, your angles will, in increases by minus 90 degrees. Okay, so if it's simple integrator is minus 90 degrees. If it's double integrator is minus 90 degrees minus 90 degrees, which is minus 100 degrees. And then for triple one is minus, and then minus again. And then for the quadruple, which is, going 360 degrees. So this is the general concept I want to convey. And then the second one is the one that I'm talking about, the magnitude. As your order increases, your magnitude actually moves faster. As your frequency increase, okay, as your order increase, your frequency increases. As your order increases and your frequency increase, okay, they are not related lah. But then as your order increase, and while you move your frequency, when you sweep your frequency across the Nyquist plot, okay, as you increase your frequency, you're actually moving faster. Okay, so that's why I say I haven't concluded yet. So let me show you the Nyquist diagram. So this is when I plot. Okay, so this is my Nyquist system. Okay, just to let you know, this is the code. Okay, if you next time you want to key in, you can just key in over here. Okay, just follow this code. Because 1 over s squared you have to, is 100, which is s squared and then plus 0s plus 0 type of thing. Okay, just to show you lah, okay. But nonetheless, let's go back to the plot. In this case, this plot is actually 1 over s times s plus 1. Okay, so this plot is actually 1 over s plus s plus 1. So which is somewhat, I'm lagging hell. I'm lagging like you know what. So hold on a while. Hold on. I'm lagging. Never mind, I'll leave it there first. And then after that, I'll explain this one first. Next video, I'll explain this, and then I'll show you how the integrator will affect the different poles. Okay. So typically, what we're doing now is only integrators. Okay. Integrators are to so-called So I'll just continue in the next video on the rest of this is the delay lah, the lag. So in the next video I'll talk about it. So see you there.